So good day everyone. I am Rodeline Rigdora and I am going to discuss my topic entitled Investigation of Foreshock, Mainshock, Aftershock Sequence. So here, this is the greeting. So welcome Seismic Explorer. So ready to dive into the world of earthquakes. So this platform lets you uncover the mysteries of foreshocks, mainshocks, and aftershocks through interactive visualizations and seismic data. So hold on tight, the seismic journey begins now. So before we proceed to the plotting demo, which is the next page, so I will give you the brief explanation about my topic. So this investigation focuses on analyzing earthquake sequences. So how they occur in three phases. The foreshock, so it's small tremors that happen before the main earthquake. Then the main shock, so the strongest and most damaging quake in the sequence. Then aftershock, so smaller quakes that occur after the main shock as the Earth's crust adjusts. So by studying the timing, magnitude, and location of these phases, so we can better understand how earthquakes behave. So identify early warning signs and improve disaster preparedness. So the next page, which is the plotting demo. So seismic wave visualization. So foreshocks, main shock, and aftershocks. So this plot visualizes the magnitude of seismic events or over time, focusing on the foreshock, the main shock, and the aftershocks that occur in sequence. So this seismic wave visualization is designed to help us understand how the magnitude of seismic events, foreshocks, main shocks, and aftershocks change over time. So as we can see, it's still running. So at the top here, so we can select province. So in this case, we've selected Surigao del Norte. So this allows us to focus on a specific geographic location and analyze the earthquake activity here. So this is the magnitude and this is the time relative. So here in the center is our graph titled Seismic Wave Visualization. So the blue spikes, this one that's still moving, so represent the magnitude of each recorded seismic event plotted against time. So this is the time. So these are separated by when they occur. Some happen before the main shock. One is the main shock itself, and the rest are aftershock. So here, this dash line, the red dash line, this is the average magnitude, which is 2.5. So we also notice a red dashed horizontal line, this thing. So this marks the average magnitude of all events in the selected province. So it provides a useful reference to help us spot any events that are significantly stronger or weaker than the rest. So this graph gives a clear picture of how seismic intensity evolves. This visual tool is especially helpful for comparing event patterns. So studying the energy flow and identifying key seismic phases. So it's a simple yet powerful way to interpret earthquake data over time. So the next page is the mapping demo. So this is the earthquake mapping demo. And so this tool shows earthquakes as foreshocks, mainshock, and aftershocks on a map. So this is the map. So first I will remove this so that you can see the map. Then I will uncheck this. So so this feature is all about where the earthquakes occur on the map. So this is the Philippine map and how they relate to each other in terms of foreshocks, main shocks, and aftershock. So this is the each point on this map represents an earthquake event. So color coded based on its rule in the sequence. So the foreshock is the color blue, and this is the before the strongest quake. So those that occur before the strongest quakes, and then the red is main shock, strongest quake in the data, and lastly, the color green aftershocks, so happen after the main shock. And here on the left side, so you'll find powerful map and data controls to explore and filter earthquake data. And here, this is the we can select the what map type you like. So we have the dark, satellite, and streets. And this is we can select to the magnitude range. This is the date range, and we can select provinces. So we will choose the Surigao do Sur. And then this is the layer option. So we can also switch on additional map layers. For example, the scatter plot layer, so shows individual quake points. The hexagon layer groups events into heat zones to show density. Arc layer can show direction or linkage. Then the outbound layer, so shows the quakes spread. Uh, let's check the scatter plot layer. And here, where the Surigao del Sur that we selected, and this is the blue represents foreshocks, and we can see the aftershocks. And let's check the hexagon layer. So this interactive map is crucial tool for visualizing the spatial relationship between seismic events. So it gives us insight into where earthquakes are most active and how they evolve geographically. This is, and then, so the next page, so in this section, so is all about the data behind the visualizations, which is the data frame and graph. So it combines both the earthquake data table and graph that help us better understand seismic trends. So in the left side, so we can select province what we want. So in the mapping, we selected the Surigao del Sur, so we will select the Surigao del Sur 2. So this dashboard displays earthquake data including foreshocks, the main shock, and aftershocks. You can explore events by province and visualize seismic wave activity over time. So this is the raw earthquake data. So this table shows the full data set containing timestamps, magnitudes, locations, and province information. So here we can see the date and time, the latitude, longitude, depth, the magnitude, and the location. And this is the foreshocks. So these earthquakes events that occurred before the main shock in the selected dataset. So the main shock. So this is the strongest earthquake recorded in the dataset. So it serves as the central reference point. And the Batanes during April 3, 2024. And the aftershock. So these events occurred after the main shock. So that's what we feel the many shaking, but we can feel because it's too. So they are usually smaller but still significant. So this is the seismic wave visualization for Surigao del Sur. We selected the select province. So this animated graph shows how the earthquake magnitude changed over time in the selected province. A dashed red line marks the average magnitude of events to help visualize the intensity. So this is the average, this red dashed line. It's still running. So, so having both of the visual and tabular data side by side gives us more complete understanding of seismic sequences. So we can see the patterns on the map and then analyze the exact numbers behind them right here. And by the way, this table is filterable, so you can sort by magnitude or date to focus on specific events. And here is the title. So, Investigation of Foreshocks, Mainshocks, Aftershock Sequence. So, this project investigates the seismic sequences of foreshocks, mainshocks, and aftershocks in the context of earthquake studies. So, I have three objectives. So, analyze the temporal and spatial distribution of foreshocks, mainshocks, and aftershocks. So, number two, visualize the seismic sequence using geospatial and scatter plots. So, where we can see in the mapping, and the last is explore the relationships between foreshocks and mainshocks in earthquake events. So, this is for the Surigao del Norte. We can select province here on the left side, and let's select this Surigao del Sur. So this is for the Surigao del Norte and the data statistics. And that's all. Thank you for watching.